All right, so in order to do well in this chapter, we got to go back to something you should have learned in Algebra 1. It's going to be simplifying radicals. First of all, a radical is something that looks like this. It's just your square root sign. We also have cube roots and fourth roots and stuff like that, but we're not going to deal with those. So whenever I mention a radical, I'm looking for your square root sign. Here's some special properties of radicals and or square roots, so make sure you got these down. Basically, if we are multiplying two things under the same square root, I can separate them. Sometimes I might have something with them separated, like the square root of 3 times the square root of 2, and I can put them under the same square root. Same thing when we're dividing. If they're under the same square root, I can split them up, or if they're split up, I can put them here. The only way you're going to know when to do what is by practicing. The more you practice it, the more you look at a problem and you'll say, okay, I know what to do here. The last main property I want you to see is like if we have the square root of a number times the square root of a number, it's going to be that number. So that's same like the square root of 2 times the square root of 2 is going to be the square root of 4. The square root of 4 is 2. So when you multiply two numbers that both are under the square root by each other, you're just going to get that number. Those square roots are going to cancel out. You don't need to write those examples down, although you're welcome to. Just make sure you have these properties down. Now notice that none of my properties are looking at adding or subtracting. We can only split up our radicals or put them under the same radicals if we're multiplying or if we're dividing. All right, if we're adding or subtracting, we cannot do this. This doesn't make any sense at all mathematically. So just make sure that we don't do this when we're adding and subtracting, only when we're multiplying and dividing. Make sure you take down these steps so as soon as it stops writing, pause it, make sure you got it down, and then when it starts writing again, same thing. All right, the first thing we're always going to do is we're going to simplify as much as possible. We might put radicals together, we might split them up, just kind of practicing with them. Like I said, the more you practice, the more you'll know what to do. We'll simplify as much as possible first, and then our second step is our big one. We're going to find perfect squares to take out of our radical. And by take out, perfect squares are numbers that are like 1, 4, 9, stuff like that. We will look at those in a second. I'm going to give you a big list of them. But one way to know what perfect squares to take out are going to be right here in pink. Okay, so what we're going to do is we're going to take what's underneath the radical. So like if we're looking at the square root of 42, I'm going to take 42 and divide it by 2. And that's going to give me some kind of number. Actually, let's go ahead and do that. And I know 42 divided by 2 is, what, 21? So then I'm going to go to step B, and I'm going to find a perfect square that evenly divides into that number that is less than or equal to A. So I'm going to look at all of my perfect squares that are less than or equal to 21, which are going to be like 16, 9, and 4. And I'm going to say, okay, well 42 divided by 16 is going to be not a whole number, so we're not going to use 16. Same thing with 9, and so on and so forth. So what we do is we'll look for a number that evenly divides into the number I'm starting with, so that would be my 42. No numbers would end up dividing into 42, so we're just going to leave that, let it go. And I'll show you kind of what this means in a few minutes. But this is step A here is kind of going to be like a cap of what I don't need to look at anymore. So that's the top highest biggest perfect square that I can look at. We're going to look at all of them underneath it until I find one that divides into the number evenly. Once I do, I'm going to take out my perfect squares, and I'll show you how to do that in a few minutes. Once I take out my perfect squares, I'm going to simplify as much as I can, and then I'm going to ask myself if I have a radical in my denominator. If I do, I have to rationalize it. If I don't, you don't even need to worry about that. So I'm going to show you how to rationalize your denominator in a few minutes. I want to first practice simplifying, so let's look at an example. Nope, I lied. First, we're going to look at the perfect squares you need to know. What I would do if I were you is I would write down all the perfect squares that I don't know off the top of my head. If your elementary school is anything like mine, you would know up to 12 squared. Alright, my perfect squares here are 1, 4, 9, 16, 25, 36, 49, 64, all the way up to 256. So those numbers that are on the right side of your equal sign are your perfect squares. I know when I was in like 5th grade, we had to know up to 12 squared, or 12 times 12. But make sure you got all of these because you're going to be looking for these numbers in much bigger numbers, if that kind of makes any sense at all. So make sure you got these down, and then we'll try an example. Alright, so I want to simplify the square root of 27. Step 1 was to simplify as much as possible using my properties. Here I don't have any fractions or anything to multiply, to split them up, or simplify at all. So I'm going to go to step 2, and I'm going to look for my biggest perfect square. So I know that my biggest perfect square is going to be less than or equal to 27 divided by 2. 27 divided by 2 is 18.5, so that's my cap. So I'm going to look at all of my perfect squares that were from my previous slide that are less than or equal to 18.5. So they are 16, 9, and 4. Now my goal is to find a perfect square that evenly divides into 27. So it's going to be a number that divides into 27 gives me a whole number. When I look at 27 divided by 16, I type that in my calculator, I get 1.6875. This is not a whole number, so I know I'm not going to use 16. So I'm going to look at 9. And here, 27 divided by 9 is a whole number, and it's 3, so I know I'm going to use that. So I'm going to come up here, and I'm going to say 27 is 9 times 3. Alright, all I've done is I looked at their factors. Then I'm going to use my properties that said if we have two numbers that are multiplying under the same radical, I can split them up. Alright, so that was a property that we just wrote down. And I'm going to say this equals square root of 9 times the square root of 3. The whole point is that I'm taking out this square, or perfect square. So I'm trying to figure out numbers that I can take the square root of, and I know I can take the square root of 9, and that's 3. I don't know the square root of 3, so I'm done. I leave it just like that. That's my perfect, exact answer. I didn't have to round it whatsoever. Alright, so we just go in, look at this number, divided by 2, that's my biggest number. Then I look at my possible perfect square roots, or perfect squares, and I figure out which one gives me a whole number, and I use that to simplify. Alright, here's another example. This is going to be one of the ones where we simplify first. It'll make our life a lot easier. So if you notice, I have the square root of 2 divided by the square root of 200. And since those are both under a radical, I can put them under the same radical. And then what I'm going to do is I'm going to use that in order to simplify. If you notice, my greatest common factor in 2 and 200 are both 2. I know 2 goes into 2 one time, and 2 goes into 200 100 times. So I'm left with the square root of 1 over 100. Now, what I can do is split them up again. So now I'm left with the square root of 1 over square root of 100. And now I'm going to do this because I know what the square root of 1 is, and I know what the square root of 100 is. The square root of 1 is 1, and the square root of 100 is 10. Alright, I'm going to ask myself if I can simplify any more. Fraction-wise, I cannot. I don't have any radicals to simplify anymore, and I don't have a radical in my denominator, so I'm done. Alright, so here's a slightly harder one. First thing we're going to do is, again, simplify as much as possible first. So I'm going to put them under the same radical, and I'm going to ask myself my greatest common factor. All right, 3 goes into 24 8 times and 27 9 times, so I'm left with the square root of 8 over 9. I'm going to split them up and see if I can simplify it all. All right, I know the square root of 9 is 3, so let's go ahead and get that out of the way. Then I'm going to look at 8. All right, I'm going to ask myself if there's a perfect square that goes into 8. So I'm going to take 8 divided by 4, so my possible perfect squares are 4 and 1. So I'm going to look at 4. 8 divided by 4 is 2, so I know I'm going to use it. I'm going to split 8 up into 4 and 2. So right now I'm left with the square root of 4 times 2 all over 3. I'm going to split up 4 and 2 because I know the square root of 4 is 2. And I'm done. I'm going to ask myself 3 questions every single time. Can I simplify my fractions at all? Nope. Can I simplify my square root at all? Nope. And do I have a square root in my denominator? No. So I know I'm done. So let's look at what happens if I do end up having a radical in my denominator. All right, this is called rationalizing your denominator. So here, I can't simplify 1 over the square root of 3 at all anymore. All right, I can't simplify my fractions. I can't simplify my radicals. So I got to ask myself my third question. Do I have a radical in my denominator? And my answer is yes. All right, now I totally made this up. I didn't make it up. But what I do is I think about my uh-oh. My uh-oh is my square root of 3. So what I do is I multiply my numerator and denominator by my uh-oh. All right, and that's what it means to rationalize your denominator. All right, so here my uh-oh is the square root of 3, and I'm multiplying the top and bottom of my fractions by the square root of 3 over the square root of 3. What happens, What happens is here I get 1 times the square root of 3, which gives me the square root of 3. And then think back to your properties we wrote down. When we had a square root of a times square root of a, that left me with a. All right, this is the square root of 3 times square root of 3. What's happening is this gives you the square root of 9, and the square root of 9 is 3. So here I have my final answer. That's how we rationalize the denominator, and I know it's a pain, but you got to do it. So let's practice an example. All right. Here I get 9 over the square root of 27. I can't put these under the same radical because 9 is not under a radical. So I can't simplify it all, so I got to look at my radical and simplify that. So I'm going to take 27 and divide it by 2. These are my possible perfect squares. We already know that 27 divided by 16 was like, I think 1.6 something, so we knew 16 was not a perfect square that we could use. However, like in our previous example, 27 divided by 9 is a whole number, so I'm going to use that. I'm going to split 27 up into 9 times 3. So I get 9 over the square root of 9 times 3. Then I'm going to split 9 and 3 up. Take the square root of 9, I'm left with 9 over 3 times the square root of 3. Now here, I can simplify my fraction sum. I know 3 goes into 9 and 3, and I'm left with 3 over the square root of 3. Now I'm going to ask myself if I can simplify my fraction anymore. I'm going to ask myself if I can simplify my radical anymore. My answer to both those questions is no. So now I got to look to see if I have a radical in my denominator, and I do. So square root of 3 is my uh-oh, so what I have to do is multiply the top and bottom by my uh-oh. All right, here I'm left with 3 times the square root of 3, and down here I'm left with 3. So now I'm going to ask myself, can I simplify my fraction at all? My answer is yes. I have a 3 in my numerator and denominator. So my final answer is just the square root of 3. So now can I simplify my fraction at all? No. Can I simplify my radical at all? No. Do I have a radical in my denominator? No, because this is square root of 3 over 1. so I know I'm done. Let's try, here's one more example that you have on your homework, and it's going to be solving for x. All right, my goal is to first get x squared by itself. Then I'm going to take the square root of both sides, and when I take square root of both sides, I'm either going to get a whole number or I'm going to use what we just learned to simplify as much as possible. So when we're getting x squared by itself, is just like getting x by itself. So here my first step is to add 1 to both sides. When I do that, I get 2x squared equals 50. Then to get x squared by itself, I divide by 2. I'm left with x squared equals 25. Now I take the square root of both sides, and I'm technically I'm left with plus or minus 5. Although if you get x equals 5 for the purposes of my class, you are fine. But when you go to Algebra 2, don't tell your teacher that I lied to you. It is technically plus or minus 5. All right, and we're done. So if you have any questions, please get them answered now. But for the most part, you're going to get your questions answered by doing your homework. So please, please, please do all of your homework and try really hard, because once we start applying this in my class, it will either make you or break you grade-wise.